All right, this is AP Calculus ABB. We're in Unit 5, Lesson 6, Circular Cross Sections. There are three basic problems we want to address in this lesson. One is using something called the disk method. Another is called using the washer method. And then another is what happens if the rotation is not on the x or the y axis. So here's the big idea. Let's say we have a shape defined by a function. Okay, here's 0, 0, and we're going to go out to 1 right here. So this is 1, 1. And we're going to graph the function y equals x squared, which has this general shape. Okay, but what I want to do is find the volume, of the solid formed by spinning y equals x squared about the x-axis. Okay, so what's going to happen here is we're going to imagine, if you will, putting this x-axis line in a drill chuck and spinning it. Okay, what solid would you see? Well, you would definitely see it down here, right? And it would follow this general shape. Okay. And it would, in rotating, create horizontal circles. In fact, why don't I use my drawing tools here? Okay. We'd end up with a circle of rotation like this. And I misdrew that. Okay. So we'd have a circle of rotation like this. So it'd create kind of this funnel shape rotation. Okay. A little hatching to give it a 3D appearance here. Okay. Now the question is, what is the volume of the solid? Well, we'd want to, just like we talked about in the last lesson, divide this thing into slices. So I'm going to divide it into slices vertically here. So here's one slice. And we're going to make it paper thin, really thin, but that's delta x thin, right? So what is the volume of that disk? Now the volume of a cylinder is pi r squared h, right? All right, so in this case, r, what is r? R is the radius of the circle, which is defined by the function y equals x squared, right? So r equals x squared. H, the height of the cylinder, is delta x. So the volume is pi x squared delta x. Or the volume in this case is pi x to the fourth delta x. Now recognizing that as a sum of slices that are going to get infinitely thin, and we're going to multiply the slices, that is the definition of an integral. So the volume of the total bell shape of rotation is the integral from 0 to 1 of pi x to the fourth dx. Okay, and let's go ahead and finish it. X to the fifth, 1/5, so pi over 5, x to the fifth from 0 to 1 1 is real easy. It's just pi over 5. And 0 is really easy, minus 0, so it's just pi over 5. Pi over 5. Okay, which is what, about 0.6 or something like that. Pi over 5. Yeah, it was really close, 0.62, 663. Okay. All right, so that's called the disk method. The disk method. Okay, or disk with a C. Now, what if we're combining, and what if we hollow out this bell, right? Here's another problem. We have enough time. Let's go ahead and do it. This is the washer method. What if we have a shape bound between two slices, or two curves? So 2, 4, 5. So between 0 and 1, and we have y equals x. Y equals x, which is the diagonal, and y equals x squared. And we take and spin this about the x-axis. Okay. Spin this around the x-axis. Okay. In this case, we would have this shape here. Let's see if I can draw it. Okay, kind of like this. And when we spin it or rotate it, we get this shape right here. Right? It would have kind of a funnel look on the inside and a cone look on the outside. Okay, so what would the vertical slices look like? Well, we would have a circle on the outside and a circle on the inside. And that would have thickness like so. Get this to look right here. All right. And creating a washer shape, right? Like the washer you put on a bolt. Okay. And so what is the volume of the washer? Well, it is, let's find the volume of the washer. Well, let's find the area of the washer without the thickness here. It's pi big R squared, where R, capital R, is the big radius, minus pi little r squared. If we factor pi out, we get pi big R squared minus little r squared. Okay. Now in this case, big R is y equals x, so x. And little r is y equals x squared, so x squared. So the area of my washer is pi times big R, x squared, minus little r, x squared, squared. Or the area becomes pi x squared minus x to the fourth. Okay, that's the area of the washer. Now, if we find the volume of the washer, we simply multiply that by delta x, which is the thickness of the washer. And recognizing that as slices that are going infinitely thin and multiplying infinitely, and we're taking the sum, the whole shape has the integral from 0 to 1, because this is from 0 to 1, of pi times little x squared minus little x to the fourth dx. Okay? Well, let's go ahead and evaluate this. Separate the pi out. Okay, 1/3 x cubed minus 1/5 x to the fifth from 0 to 1. Not too bad. 1. This is pi times 1/3 minus 1/5. Insert 0, you get 0. So 1/3 minus 1/5. So 5 minus 3 is 2/15. So 2 pi over 15. Okay, and let's go ahead and check our work here. Let's check our work. Here's how I'm going to check it. Not chuck it, check it. All right, so I'm going to put in 2 pi over 15, and I'm going to do the definite integral from 0 to 1, pi x squared minus x to the fourth dx. Okay, there we go. So it is an agreement. We did the integral correctly. The calculator gives me a rounded answer, a decimal answer. The exact answer would be 2 pi over 15. Okay, and so that's called the washer method. I'm going to wait to do the off-center example here for another video.